If the position vector A of a point having coordinate 12, n has a magnitude of 13, what is the value of n? Okay, let us begin. First, we'll try to understand the problem graphically. For this, we are going to consider a two-dimensional coordinate system. Now, let us consider a point A. Let's say this point A has got the coordinates 12, n. Now, if we join point O and A with the help of a directed line segment, then OA is going to be the position vector of point A. However, in the problem, it's already given here that OA vector, which is the position vector of point A, it's given by A vector. Now, since we have the coordinates of the point A, we can define the vector OA, or in simple terms, the A vector, in terms of the unit vectors I cap and j cap. So I cap is going to be the unit vector along the x-axis, and then j cap is going to be the unit vector along y-axis. Now, from point A, we're going to drop a perpendicular on the x-axis. Let us suppose that the perpendicular meets the x-axis at the point M. Similarly, we're going to drop another perpendicular from the same point A on the y-axis. So here, let's say it meets the y-axis at the point N. Now, what we can do? We can express the vector OA, or the position vector A, in terms of the coordinates. All we have to do is consider the triangle OAM. Here we'll be considering the vector OM vector and MA vector. So if we apply the triangle law of vector addition, then in triangle OAM, in this particular triangle, OA vector, this is going to be given by OM vector added to MA vector. However, since OMAN is a parallelogram, OM vector plus MA vector, and in place of MA vector, we can replace it with ON vector. Since MA vector equals to ON vector. The reason why we're using ON vector, because ON vector gives us the component of the vector A along the x-axis. Because what is OM here? OM is nothing but the x coordinate of point A, so that's 12. But 12 is a scalar value. In order to express it in terms of a vector, we're going to multiply it with the unit vector I cap, indicating that it's along the x-axis. Then what is ON vector? ON vector is simply going to be the y coordinate of the point A. The y coordinate of the point A is, that's n. Now n being a scalar value, we're going to multiply it with j cap, indicating that's along the y-axis. So here we have A vector. OA vector we're replacing with A vector. So we have expressed A vector in terms of the unit vector I cap and j cap is 12 I cap plus n j cap. Okay. Now it's given the absolute value of A, or the magnitude of the vector A, that's defined as take the square root. Underneath the square root, we take the component of I cap, which is 12, and then we're going to square it, and then add it to the component of j cap, which is n in our case, and we're going to square this value as well. It's given here that the magnitude of vector A, that's 13, so 13 is going to be equals to the square root of 144 plus n squared. So let's solve for the value of n. Now we have squaring both sides, we're going to get 169, so that's the square of 13, so this is going to be equals to 144 plus n squared. Solving for n squared, we get n squared equals to 25, which means that n value is going to be plus or minus 5. So it could be either plus value or minus value. So it could be both of the two values. So if we consider n to be positive, then we have one value is 12, 5, indicating that it's in the first quadrant because both x and the y values are positive. And if we consider the n value to be negative 5, then in that case, we have the point lying in the fourth quadrant where the y coordinate value is negative. We have successfully obtained the value of n, so n comes out to be plus or minus 5.